4.2 Chapter 42 Protection against thermal effects. Chapter 42 addresses protection against thermal effects, emphasizing the need to consider potential heat-related risks associated with electrical installations. Thermal effects must be considered in the design phase of every electrical installation. 4.2.1 discuss the need to consider thermal effects in all aspects of design. Consideration of thermal effects in design is crucial for several reasons. Normal operation. Electrical equipment generates heat during normal operation. Designers must ensure that this heat does not pose a risk of fire, burns, or degradation of materials. Fault conditions. Faults such as overloads or short circuits can cause excessive heat. Protective devices must be selected and coordinated to limit the duration and magnitude of fault currents, thereby minimizing thermal stress on conductors and equipment. Equipment selection. Electrical equipment should be selected to ensure its lifespan will not diminish, and it is suitable for its environment. Environmental conditions. The ambient temperature, presence of flammable materials, and other environmental factors can influence the thermal performance of electrical installations. Designers must account for these factors when selecting equipment and designing wiring systems. Compliance. Installations should comply with manufacturer's instructions in order to avoid the risk of fire. Mitigation. Designers should seek to mitigate the risk of high temperatures and minimize the potential for degradation of materials. 4.2.2 cover protection against burns, fire hazards, ignition of flammable materials, and overheating. Chapter 42 provides measures to mitigate thermal risks. Protection against burns. Equipment that may be touched during normal use must have surface temperatures limited to safe levels. Table 4.2.1 specifies the maximum permissible temperatures for metallic and non-metallic surfaces, depending on whether the equipment is intended to be held, occasionally touched, or not touched at all. Protection against fire hazards. Where a particular risk of fire exists, measures must be taken to prevent the ignition of flammable materials. This may involve enclosing equipment in arc-resistant materials, screening materials, or maintaining safe distances from combustible materials. Arc fault detection devices, AFDDs, are recommended as a means of providing additional protection against fire caused by arc faults. Ignition of flammable materials. In locations where flammable materials are processed or stored, special precautions are necessary. Where there are significant quantities of liquids, provisions should be made to ensure they will not spread. Luminaires must be positioned at an adequate distance from any combustible surface. Prevention of overheating. Equipment enclosures must be ventilated to prevent the buildup of excessive temperatures. Overcurrent protective devices must be selected and coordinated to prevent conductors and equipment from overheating during overload or fault conditions. Wiring systems should be selected and installed to minimize the risk of fire-related collapse. Electrical connections should be properly made and protected to prevent overheating. Thermoplastic cables have a limiting temperature of 70 degrees, while thermosetting cables have a limiting temperature of 90 degrees. IP ratings. Equipment with adequate IP ratings should be used. By addressing these considerations, electrical installations can be designed and installed to minimize thermal risks and ensure the safety of people and property. 4.2.3 explain the importance of fire-rated consumer units and the selection of wiring systems to prevent fire spread. Fire-rated consumer units. In domestic household premises, consumer units and similar switchgear should comply with BSEN 61439-3. The enclosure of these units must be manufactured from a non-combustible material or be enclosed in a cabinet or enclosure constructed of a non-combustible material. Ferrous metals such as steel are deemed to be examples of non-combustible materials. The purpose of this regulation is to contain any fire within the consumer unit, preventing it from spreading to the surrounding environment. Selection of wiring systems to prevent fire spread. Wiring systems should be selected and installed to minimize the risk of fire-related collapse. Wiring systems must be supported so that they are not liable to premature collapse in the event of a fire. Cables should have a minimum light transmittance of 60% when tested in accordance with BSN 61034 to 2 and a limited flame propagation. Cables should meet the requirements of BSEN 60332-3 or, where cable management systems are used, cables should meet the requirements of BSEN 60332-1-2. PVC trunking is no longer compliant in protected escape routes because it gives off large amounts of black smoke and toxic gases when burned. Wiring for control and bus systems of safety services must comply with the same requirements as the wiring used for the safety services. 4.2.4 discuss the use of arc fault detection devices, AFDDs. AFDDs are recommended as a means of providing additional protection against fire caused by arc faults. AFDDs monitor the waveform and identify distortions related to arcing events. They work with both parallel arcs, arcs between conductors, and series arcs, arcs in a single conductor. AFDDs should be installed at the origin of the final circuit to be protected. AFDDs conforming to BSEN 62606 are recommended for single-phase AC final circuits, supplying socket outlets, and fixed current using equipment not exceeding 32 amps. However, AFDDs may be omitted where unexpected disconnection in a circuit would cause danger. Examples of where AFDDs may be omitted include the exciter circuit of a rotating machine, the supply circuit of a lifting magnet, a circuit supplying a fire extinguishing device, and a circuit supplying a safety service. The use of AFDDs does not remove the need to apply other protective measures. AFDDs include thermal and magnetic protection within a standard MCB, RCDs that deal with earth leakage, surge protection against overvoltages. AFDDs are designed for the domestic market, are single-phase, and do not have the pollution category necessary for commercial or industrial use. There are concerns about whether the industry has been adequately trained on how to select and erect AFDDs. Making AFDDs mandatory could increase the cost of a fuse board.